So henceforth, I take your physics lectures, and the topic I'll be starting today is spectrum. Okay. So is it taught in some of your colleges or schools? For you it is? Chapter 6. So in this chapter, primarily there are three topics. One is deviation, then you have dispersion, and then spectrum. These are the three topics. So I'll basically my lecture flow is based on Selena. Okay. So most of you are following Selena or Selena? All right. So let us understand deviation. So I'm sure you have gone through refraction of light, right? So you have basic idea of deviation. So what is deviation of light? The bending of light and passing through one transparent medium to another transparent to the other, right? Yeah. So that is deviation, right? So we'll see it in case of a prism. Yes. So deviation in case of prism. So the prism that we'll be using is equilateral prism, and this is the cross section, right? Yes, sir. So BC is the base, and what is AB and AC? Refracting surface. Refracting surface or lateral surface. Okay. So let us say the incident ray falls at the midpoint like this. Right, so this is a monochromatic ray. Yes, sir. What is monochromatic? Sir, single color. Sir, white. Not white light. It's a single color ray. Any color, red, green, any. Okay. So to make the deviation, what do we do? Normal. So this is the first step. You have to draw the normal at the surface. Now, prism is glass prism. So, is it a denser or rarer medium? Denser. Okay. So, this is denser. So, what was the original direction? This was the original direction, right? And this is the normal. So, it will bend towards the normal, right? Towards the base of the prism. Right? So, therefore, this is what is the refracted ray inside the prism. Okay. So let's name it. Let's call this P, Q. And again, over here, we'll draw the normal again, right? So this is the normal again. So what is the original direction? This is the original direction. And it will bend away from the normal. Okay, so P, Q, R, S. So what are these rays? This is incident ray, you are familiar. Incident. This is refracted and this is emergent ray. Okay, so you are already familiar about it. Now, what are the deviation? Where is the deviation? This and this, right? Yes, sir. So this is your deviation. What is angle of refraction? Sir, angle between the normal and the refracted. So this is the angle of refraction. Okay. What is angle of incidence? Sir, angle between the AC and the normal. So anyway, we are not concerned about angle of refraction over here. So let's leave it at deviation. Okay. Okay, this you have already done in refraction of light through plane surface. Chapter 4 you have already done. Now, this is the first deviation. Again, there is a second deviation over here. So, what is the deviation here? This one. So, what is total deviation then?
Delta 1 plus delta 2.
So, total deviation extended backward, right? So, this angle delta 2, this is a vertically opposite angle. So, this also will be delta 2. What is total deviation? This is the total deviation. So this exterior angle will be equal to sum of interior opposite angles. Total deviation is equal to delta 1 plus. Is it understood?
Yes, sir.
Okay. Now, so what this total deviation depends on? Factors on which depends. What are the factors?
Angle of incidence, angle of prism, and the refractive index of the.
So angle of incidence. I. How does it depend on angle of incidence I?
The angle of incidence increases.
Listen to the question before answering. I am asking how does angle of deviation depend on angle of incidence?
If the angle of incidence changes, the deviation would change. Because it would.
You remember this graph?
Yes, sir.
This is how it is.
Minimum deviation.
Yes. So what is it? Delta. This is angle of incidence. So initially, when the angle of incidence increases, the deviation decreases.
Yes.
It hits a minimum value, and then again it increases. Okay. So this is delta. No. So it decreases for some time with rise in I, and then it increases. Okay. So it has both dependencies. So anyway, in this chapter we are not discussing this, right? In this chapter we'll discuss about the deviation due to color of light.
Yes, sir.
Right? Now just for the sake of completing all the factors, first was angle of incidence, second is angle of prism. Yes, angle of prism. A. Right? So if the angle of prism is more, the deviation will be more. Okay, it is directly. Third is it depends on the material of the prism. That means it depends on refractive index. So depends on mu. Yeah. Depends on mu. That is refractive index, which then depends on material, which also depends on color. Color. Yes, and color is governed by wavelength of the light, right? So we will not write it as a separate point. I will write it as material or color or wavelength. Okay, so color or wavelength, material, these are all interrelated. So I'm not writing it as a separate point. So let us focus more on how the dependency on color takes place as with respect to deviation. Okay. So again, wavelength and refractive index. What is the relation?
Wavelength F is equals to V is
lambda 1 by lambda 2. Lambda and density medium by lambda.
Refractive index is this formula, right? C by D. You know this, right? C is constant.
speed of light in air.
Mu is equal to
C
C
is
by
equals to speed of light in air.
Okay. Let's say The material of the prism is glass. So refractive index of glass is C by VG. Okay. Now, so what is C? C is constant.
Speed of light in air medium. 3 into 10 raised to 8.
Don't be in a hurry to answer. Okay. So just wait. Right. Don't be in a hurry to answer. Let the concepts go inside. So when I'm asking, don't answer everything. Okay. I will give you a chance. I'll turn like this and ask. Then you answer. So refractive index of a glass in terms of ratio of speed of light is given as C by Vg. But C is constant. Yes. So can we say that mu G is inversely proportional to speed of light in the medium?
Yes, sir.
Okay. Now what is Vg?
The speed of light in glass.
Frequency times wavelength, right? Okay.
Yes,
Okay, wait. Let me write it over here. C by F.
Yes, sir.
Can I write like this?
Yes, sir.
Frequency also is constant. So C is constant and frequency is constant. So can we say therefore, but C and F is constant? Is frequency constant?
Yes, sir.
Yes, sir.
Okay. Therefore, mu G is inversely proportional to wavelength of light in the medium. Clear? So therefore, if the wavelength decreases, the refractive index increases. Now you know that wavelength for red is maximum. What is wavelength of red color? 8,000 angstrom. And what is it for violet color?
4,000.
Yes, 4,000 angstrom. Right. So therefore, mu R for maximum wavelength, the mu R will be least. Is least. Right. And mu V is maximum. Okay, and we know when the refractive index is more, it will bend that light more. So which color will bend more?
Sir, violet.
Violet.
Perfect. So all the deviation is understood now.
Yes, sir. Yes,
So
sir.
violet color will bend maximum because its wavelength is least. Yes. Least name most. More violet. तो ये सबको समझ आ गया?
Yes, sir.
Okay. So having understood the deviation, so this is it. So you can note it down if you want to. Ray diagram बना Yeah, it's very simple. How many lines? 6 lines. Which came first?
ये वाला कितना
We are just starting. अच्छा इसमें जो योगिता मैडम
ने इधर तक पढ़ा था ये इधर
अच्छा ठीक है
फर्स्ट टाइम पेपर ये वाला हो गया ये वाला
This is basically method to find out the focal point. ठीक है तो कोई ऑब्जेक्ट नीचे है हमारा विंडो के बाहर ट्री वो ऑब्जेक्ट हो गया ऑब्जेक्ट है और जहाँ पे क्लियर इमेज है वही डिस्टेंस फोकस हो जाता है ये तो आप तो अभी ऑब्जेक्ट ट्री की बजाय डायरेक्ट में तुम क्या लेते हो ये उसका रेट तो बाहर ट्री की है लेट्स आगे यहाँ अब हमने यहाँ पे क्या करा इसका जो इमेज बनेगा ठीक है वो वर्चुअल ऑब्जेक्ट फिर उसका इमेज यहाँ पे ठीक है इसको ऊपर से देखोगे ना, ये जो रिफ्लेक्टेड इमेज है, ये आगे इसके ऑपोजिट में मैच होगा. When you move your eye, दोनों साथ-साथ move होगा.
हाँ सर हमने किया है.
तो यहाँ पे साथ-साथ move होगा. That distance. तो अभी दो distance हो गए. ऊपर से नीचे से एवरेज डिस्टेंस. ठीक है. वो टोटल है. ये जो ऊपर से गया था, वो सामने से गया. ये थोड़ा मिरर है और ये लेंस है. ये ऑब्जेक्ट ऊपर होगी. तो मैं ऊपर भी होगी. जब आई को साइड में करोगे तो दोनों पॉइंट पे साथ में तब तक एडजस्ट करो जब तक ये पॉइंट पे दोनों साथ साथ घूमे वो डिस्टेंस So, so I would basically go concept wise. Okay, whatever mode you want to do that. Yeah. Notes is also already there. So there will be mostly in discussion. Yes. Coming to the topic next. Right now it is monochromatic. Understand deviation. So these are the concepts. The refractive index is inversely proportional. Okay. Now we'll extend it to watch light. Can I erase this side of it? ये सब लिखने की जरूरत नहीं है. You already have done it. So here we are only learning about the dependency of color of light. Color of light. We are done with deviation. Now dispersion. Now I'm changing. Next topic. So don't write the modified thing. Okay, you write the things below. Now we will have white lines. When we have white light, what happens now? So I'm going to erase this. Can I? Yes, you can erase it. Okay, everybody done writing?
Yes, sir.
So let us understand dispersion now. This one. F left out. Frequency into wavelength. G is wavelength inside the prism. Mu G. Not green. Mu G. Wavelength in the medium. G is for glass, wavelength in the medium. It's not for color. G is glass. So can I explain now? Now let us say, okay, silence, front bench, focus. Attention everybody.
Yes, sir. Yes, sir.
So when the white light is incident on face AB, now what is observed? Okay. Hang on, man. Hang on. Let me teach. Just hang on. Let me specifically ask you a question. Okay. Yeah. So nothing wrong. Just hold your urge. Huh? Now. So here, what we see is, we see that we get a band of colors now. Yes, this is what we get. So which color will be on top?
Sir, red. Minimum.
Why? Least deviation.
Sorry.
Red is least deviation. So this also will be least. Okay,
Yes, sir.
And here this will be maximum. Least and maximum. Having understood the deviation, more wavelength, least deviation, right? What about the speed then?
The speed would be red speed.
जिसका wavelength ज़्यादा होगा उसकी speed ज़्यादा होगा. Because speed depends on wavelength, right? Vg is equal to f lambda g. तो ये constant है. Vg is ठीक है. जिसका wavelength ज़्यादा होगा उसका speed ज़्यादा होगा. भाई relation change हो रहा है. जिसकी wavelength ज़्यादा होगी, wavelength means distance traveled in one time period.
Yes, sir.
Okay, so जिसकी wavelength ज़्यादा होगी, one time period में वो ज़्यादा distance cover करेगा ना. So red will travel the fastest because इसकी wavelength ज़्यादा है. Okay, so deviation is less because of two things. One is refractive index is less. Second is speed is more. So it travels so fast that gets less opportunity for bending. Okay, so therefore ये वाला जो कलर होगा ये क्या होगा? Red. ये क्या है? That's it. And in between we get different colors. We get blue, green, yellow. So you need not draw 7 different lines. Just the top and bottom is enough. And but label it this way. So all the other colors in between. Is it okay?
Yes, sir.
So now what is dispersion? Dispersion is
Splitting of white light.
yes. So this white light. Hello, so much of background noise. Let only me be the speaker, okay? नहीं तो मजा नहीं आएगा किसी को सुनाएंगे. So what is dispersion? That's what we are discussing.
Yes, sir.
The splitting of white light inside the prism.
7 different colors.
7 different colors is called dispersion.
Yes, sir.
While the splitting is happening due to different deviations.
Different frequencies.
Not frequencies.
Sir, frequency
Same as of the wavelength.
Frequency change.
Whatever is the
Frequency depends on the
white light is traveling at the speed of light outside, which is C. All colors, all component colors of white light are traveling at the same speed. Where? In air.
Yes, sir.
But in the glass, the speed changes. Okay, because they suffer different bending. Okay, different refractive index. So that is why the white light now splits into its component colors. This is called dispersion. Right? So splitting of white light. Splitting of white light into its component colors. While passing through the prism. Through the prism. It is called dispersion. Okay, so the process of splitting of color into component color is dispersion. Where does it take place? Which phase? AB. Okay.
Yes, sir.
So dispersion means dispersion takes place on phase AB. What about phase AC? So only refraction or deviation. Here it is deviation plus dispersion. Out here it is only deviation or refraction. Okay. Deviation, refraction is the same thing. Is it clear? Yeah. Different interpretation.
What is this?
What is this?
So what do we get?
नहीं, but फिर भी
What is this? What is going on? So what is it? This is band of colors.
band of 7 colors.
7 colors. Right. It's called spectrum of white light. So there are different spectrums. Okay, this is spectrum of Nebula is spectrum of white light. So what is spectrum?
Spectrum is the
Band of
band
It is a band of 7 lights.
It is the arrangement of various.
when a white light passes, it disperses into 7 different
It
colors.
is a arrangement in either increasing or decreasing order of wavelength. It is perfect order. Like this wavelength O is less than R, right?
Yellow is
Less than O.
green is
So it's a degree, this is a decrease of wavelength. Okay. Got it?
Yes, sir.
So wavelength is constantly decreasing as you go from top to bottom. Okay. So ordered arrangement of various rays of light is called spectrum.
Yes, sir.
Spectrum in general. So there is an electromagnetic spectrum that is next. So we'll see that later. So spectrum for you is an ordered arrangement of rays, either in terms of frequency or in terms of wavelength. So as you go from top to bottom, what happens? The wavelength decreases. Good. What about the frequency?
Constant.
For white light, it is constant. But then there are different types of radiations in sun, right? Only white light is visible to the eyes. So this is also called visible spectrum, right?
Yes, sir.
So beyond red, you have infrared, which is not visible, but it is part of sun's radiation. Okay. Beyond violet, you have ultraviolet. That is also not visible. Okay. So those spectrums are called invisible spectrum. So we'll discuss that. Is it understood?
Yes, sir.
Yes, for you. Okay. So can I proceed or are you writing it? The spectrum of violet. So with this chapter is I think over. This unit is over. अभी आधा घंटा
सर अगला इवेंट भी खत्म करना
So what is the cause of dispersion of light? Yeah, we can do okay. There are only two lines. Is it textbook or okay, let's do some numericals. There are only two lines. Huh? Drawing the diagram. Have we missed on anything in this? Acha, in spectrum, scattering of light, that is not in the syllabus, right?
So what is
Scattering of light. That the C unit. C unit is not in syllabus. I think so. I can't see it in this year's syllabus. It's only electromagnetic waves.
So just 2 pages.
There is a chapter over only 1 unit.
No, but it's conceptual. And even in electromagnetic spectrum, write down. Even in electromagnetic spectrum, you will have properties of UV rays.
Can you repeat
Are you in your own word? Are you listening? What did I just say?
So UV that properties of the spectrum is there and infrared is there.
So UV rays, infrared rays, and visible spectrum. Only these 3 rays. There are X-rays, gamma rays. Okay, details are not in the syllabus. Like properties are only common properties. So out of the whole electromagnetic spectrum, only 3 rays we have to study.
Ultraviolet, visible light and
infrared. Only properties, uses and detection of that. Rest you just know the order.
I was not in, so can you repeat?
So this is the thing. I can't repeat for everybody. Hello. Silence, everyone. I'm going to send some of you out of the class. Hello. Soon you will go out of the class. So if I see that this is continuing, I'll have to take some more steps. So I will be silent. It's just 1 hour. And it is only 20 minutes left. Okay. So from the full electromagnetic spectrum, right, which has 7 different types of rays: gamma, X-ray, ultraviolet, pure, infrared, microwave, and radio wave. So you know the pure. Okay, pure के left side में 3 है, right side में 3. So pure के left का एक पकड़ना है. UV and infrared. ठीक है. In general, पूरा electromagnetic spectrum का knowledge होना चाहिए. And it consists of how many different radiations. So the radiations which come from sun to the atmosphere has not only visible spectrum, it also has other radiations which are not visible, but we have a way to detect it. Okay, so because of those detection, we now know that there are all these rays which I just said. Okay, तो उसमें से details खाली 3 ही पढ़ना है: UV, visible and scatter. हाँ नहीं समझाओ, तुम लोग हो तो फिर कौन मेरा बिगाड़ सकता है? Okay. Yeah, can we do the numerical now?
Yes, sir.
Okay. So in your volume, page number 107. Class work. So this is the numerical. There is a radiation whose frequency is 500 megahertz. So mega, so you have to convert it in SI unit. So which is 500. Mega is 1 million. 10 raised to 6. Mega is 10 raised to 6. 60 centimeter in meter is
0.6
meter.
Yeah. Okay. So what is velocity? So V is equal to F lambda. So this is 500 into 10 raised to 6 into 60 into 10 raised to minus 2. So how much this would be?
30,000. 30,000 into 10 to the power.
30 also. 30 to 10 power
1, 2, 3.
7. 30 to 10 power 7. 3 to 10. So 3 to 10 power 8. 10 to 10 power 8.
10 to the power 8.
Yes, sir. 3 to 10 power 8.
So what should be the medium then? Air or vacuum? Air or vacuum? Anyways, air or vacuum.
2.2.
अरे ठीक है, you take air और vacuum as same.
Yes, sir, I know.
Air में 2.99 कुछ है, but we take it as same.
सब पूरी accurate और लिख सकते हैं. पूरी accurate और इस पे. अभी साइड पे 29979.
लिखने को लिख सकते हो, ठीक है? खाली क्या है, जहाँ जरूरत नहीं है वहाँ पे स्मार्ट बनने की जरूरत है। तो वो चीजें फायदा करे बस नुकसान करे। हाँ वो पॉसिबल है। Okay. We should not complicate things where not required. Very simple. Okay. Can we go to the next numerical?
Yes, sir.
Yes. Anybody has doubt in this? I think it's straightforward. Okay. Second.
Frequency we have to find on the other line.
What is it?
Wavelength is given, frequency we have to find a pair.
So calculate the frequency. So what is 60 is equal to that lambda for f is equal to B is given as 3 into 10 raised to 8. Wavelength is 50 by 100 angstrom. Angstrom is 10 raised to minus 10.
Minus 10.
Okay. So how much is this? Just figure out. So you should get how much? 3 by 50 by into 10 raised to
B by lambda.
this is 10 raised to minus 8, 16.
So what's the value minus 50 by 100?
इसका 2 0 यहाँ पे कट कर दिया ना,
हाँ.
ठीक है? So this will become minus 8. Minus 8 ऊपर जाके plus 8. So you find out how much is this. You should get 5.4 into 10 raised to 40. कितना आना चाहिए?
Sir, that is first, right?
13 हो सकता है ना 54 into 10 raised to 13 ले सकते हैं
नहीं, ये एक स्टैंडर्ड नोटेशन है एक नंबर के बाद में. दिस इज स्टैंडर्ड साइंटिफिक नोटेशन. वन सिग्निफिकेंट फिगर एंड देन पॉइंट और उसके बाद. So there are two homework numericals also. These are the only two classwork numericals. Okay, so now let me begin with electromagnetic spectrum. There are two homework numericals. Can we do that also?
Yes sir, yes sir.
है ना? होमवर्क में तो वैसे भी इंटरेस्ट नहीं है. So let's do the homework numerical. So frequency range of visible light is from ठीक है. क्वेश्चन कंप्लीट नहीं है क्या? From 3.5 into 10 raised to 14 hertz to where is the range? कहाँ रेंज दिया है? एक ही फ्रीक्वेंसी दिया है ना? क्वेश्चन ही कंप्लीट नहीं है क्या? एक और फ्रीक्वेंसी की वैल्यू चाहिए. लेट मी सी इफ दिस इज. See, yeah, it is there in the textbook. Okay. So, so this is the frequency range. Correct the question in your volume. It is there. तो ये बहुत गड़बड़ है. वॉल्यूम में काफी सारा you will find typographical errors. So don't lose heart. Just cross verify with your textbook. Okay. So. So what is the wavelength range? So wavelength is C by F1, right? Wavelength will be C by F1. So this is equal to 3 into 10 raised to 8 divided by F1 will be 3.75 into 10 raised to 14. And F2 will be equal to C by F2. So solve this. Upon 7.5 into 10 raised to 14. Okay, so you should get this as 4,000 angstrom. Will you get it?
Sir, second one is 4,600.
No, this will be 8,000.
नहीं सर, 4,000 रहेगा, नीचे में 8,000.
Correct. Which frequency is higher?
Sir, the second one.
Then this will be 8,000. Frequency तो same होता है ना?
Sir, frequency same 3.75 रहेगा.
एक मिनट, let me check. Wait. So frequency is almost same only. The order is same. Okay. So ठीक है. ये पता नहीं क्या गड़बड़ है. Frequency should be same, right? For visible spectrum. So let me use the calculator. 3 by 3.75. So this is 8,000. This is 8,000. This should be then 4,000. So this is a hypothetical, just mathematics. By mistake, I had written here, or it is meter, right? It is meter. So what is this then? This will be angstrom. Therefore 8,000 angstrom. 1 angstrom is 10 raised to minus 10 meter. Yes. Better. I mean, wavelengths are written in angstrom. So here also it will be 4,000 angstrom. So don't get confused because I told you the frequency has to be constant. So here, over such a long range, What is changing is this and this, but the order is same. Okay, order is almost same, so you can take it as constant only, but the range of waves.
So where the 10 to the power minus 10 will go? Where the 10 to the power minus 10 will go?
Angstrom लिखिए ना, 10 to minus 10 is angstrom.
Yeah.
1 angstrom is
Yes, sir. What is it?
10 is to minus 10.
Yes, sir.
Okay. Now what is the next question? Wavelength of X-ray is calculated its frequency. Again the same thing. एक ही formula के ऊपर है. ठीक है? So can you do it?
Yes, sir. You do one, sir.
Okay. So there are still 15 minutes. I'll start with the next chapter, next topic, the electromagnetic waves. Right? What is Okay. Everybody stand up. Stand up, stand up. Yeah. Tell yourself that I am going to be silent for next 15 minutes. Tell yourself, not me. Tell yourself. I should not hear. Okay?
Yes, sir.
Sure. Sit down, sit down, sit down. So, just do this breakout in between, just to break the monotony, okay?
Yes, sir.
And I'll also do it to seek attention. So, sit down now, silently. Okay. So, I'm going to just introduce what is electromagnetic spectrum. Again, इसको यार बीमारी है. Hold it, hold it. Control. Control. No, this is like you realize, okay, ready to go. I mean, I'm yet to fire the bullet, and you're like so you'll be disqualified. You understand? So on your mark, be ready, attentive, but don't start till you are asked to. So develop this habit. This is habitual problem. Work on it. Work on it. Okay. And this guy has a very different kind of a habit. So you guys are victims of yourself. Huh? I will explain. Let him give that chance. Okay. So now, what we are discussing is electromagnetic spectrum, right? So good thing is, it is not very difficult to remember. Hello, stand up, the last bench. Stand up. दोनों खड़े रहो थोड़ी देर. खड़े रहो. वो तो नहीं बात कर रहे हो तुम लोग और यहाँ तक सुनाई दे रहा है. And next time I'll ask you to stand on the bench. Hang on. Be serious. So you start with the visible. Yes, what? Let me decide, okay? Let me decide. I am very fair, okay? So let me decide. So whom I see, okay? You telling me will not work. Let me catch him. So I spotted you both. You were in the crossfire, right? You are a collateral damage, okay? So just stand. See, when terrorists are hunted down, okay, it's not that only terrorists are killed. Some bullets kill the innocent also.
Victims.
It's called collateral damage. Can we?
Yes, sir.
So Vibgyor I explained. So what is the wavelength range?
4,000 Armstrong minutes to 8,000 Armstrong.
8,000 Armstrong. All the wavelengths. Now listen. Now this is called as visible part of the spectrum. Visible spectrum. Right? हाँ. चलो बैठ जाओ. Don't. So visible spectrum. What I explain? What is electromagnetic spectrum? Okay. Anybody heard of electromagnetic waves? What kind of wave is light wave? Electromagnetic wave.
Yes, sir.
And it is transverse.
Transverse.
Now, what is transverse? What is the difference between transverse and longitudinal?
Displacement of the particle is in the same direction.
Yeah, it's parallel to the wave. Right?
And your transverse is at right angle.
It's cross. It's transverse. Okay. So can you give me an example? Longitudinal wave is sound wave. So when I'm speaking to you, the air particles are oscillating like this. Then the next one, then the next one. The air particle near me is not reaching you. They are disturbing the adjacent particle.
Yes.
And the air molecule in your ear is then disturbing the eardrum.
Yes, sir.
So it is air to air. It's a chain.
Yes.
So the particles are disturbed horizontally, and the wave is also the energy, sound energy, is reaching you. And these oscillations are in the same direction. Now, in case of transverse wave, what any example?
So when you strike a stone on the surface of water.
Yes.
That's it.
So you put a string like this. So you see that string is going up and down. You plug at one end, the disturbance reaches the other end. So you are transmitting energy. What is wave? It is just a mode of transfer of energy. And it is transferred in terms of disturbing the adjacent particles of the medium. So what we discussed was a mechanical wave, which requires medium to travel. So sound wave or the wave in the string of guitar, or when you put a stone, drop a stone on a still water surface, water waves, right? They are all example of mechanical waves because they need medium to travel. Now light is also a transverse wave, but it does not require medium to travel.
Sir, it can travel any medium.
So from sun to earth, the medium is only atmosphere, which is roughly 300 to 400 kilometers above Earth's surface.
Yes, sir.
Beyond that is emptiness, space, vacuum. So
Vacuum.
light does travel from sun
Yes, sir.
till Earth's atmosphere in vacuum.
Sir, light is faster in light.
Fastest.
Fastest.
Yeah, TK. So that is roughly 3 to 10 raised to 8. The point here is light traveled through space, like it traveled without medium, and then it travels through medium also.
Yes,
Not
sir.
that it will not travel in the medium. So there is no condition for light के travel करने के लिए medium ही चाहिए, ऐसा नहीं है. But it can also travel through medium.
Yes.
Understood? So electromagnetic wave can travel with or without medium. That's how it is different than transverse wave of string. Okay. So now what is vibrating in light? In transverse wave, the molecules of the string they were oscillating transfer to the propagation of disturbance.
Yes, sir.
In case of light, what is it? Electric and magnetic field. So light has energy field. So the energy field are like this. So if light is traveling in this direction, the electric field and magnetic field they oscillate perpendicular to it. Right? This is the direction in which light is traveling. And this is how the electric and magnetic field vector are oscillating perpendicular to each other. So let's say this is light coming towards you. So then there is a electric and magnetic field like this. Okay, and it is 360 degree. So not just one. Got it? So there is electric field like this. So the thumb is electric, this is magnetic. Everywhere it is surrounded 360 degree. You'll learn it if you pursue science in higher standard. Okay. So electric field is coming to you and it is enveloped by energy. Okay. So energy is oscillating how? Perpendicular to the propagation of light. So electric field this way, magnetic field this way, and light is traveling towards you. Got it? That's why it is transverse wave. Now, this is visible to us.
Yes, sir. Yes, sir.
But there are other indirect methods to detect other radiations. When the radiations come in, when the radiations coming from sun were analyzed. So apart from this, other radiations also were detected. Okay. So we call them as. So it's easy to remember. Impure. बस याद आ गया तो beyond red it is infrared. Infrared rays. Beyond infra you have microwave.
Microwave and radio.
Microwave. Okay. So you call it rays, waves. It's one and the same thing. Okay. Rays are waves. Okay. The ray, the light ray, actually is a wave. It comes like this to you. Got it? So, in lower standard, you call it a ray. When you go to higher standard, you call it a wave. So, wave, ray, radiation, everything is the same. Now, you have radio wave. Okay. Now, as you go from left to right, what is happening to the wavelength? Increasing. So which radiation will have maximum wavelength? Radio waves. Okay. Now let's come to the left side.
Ultraviolet.
So violet, ultraviolet.
Ultraviolet.
Beyond this, X-rays.
And gamma rays.
Then you have gamma. Because when you go from left to right, so here wavelength will be least.
Yes, sir. Wavelength is from left to right.
This will have maximum wavelength.
Yes, sir.
With frequency, it is opposite.
Opposite because universal proportional.
So this is minimum.
Minimum. That is maximum. F max. Yes,
That's
sir.
it. So this entire arrangement in increasing order of wavelength or increasing order of frequency is called electromagnetic spectrum. So spectrum is nothing but range of rays arranged in a specific order of either increasing wavelength or decreasing frequency or vice versa. Okay? And in this, we will in the next class we'll study about properties of. So first we'll read the common properties which are common to all the radiations, right? And then specific properties of ultraviolet and infrared rays, and compare them with. We'll compare all three of them.
सर सनलाइट की सिर्फ फॉर्मूलेस होते हैं क्या जैसे
Sunlight में क्या?
सर ये सारी लाइट के फॉर्मूले होते हैं जैसे गामा का होता है 1 डिवाइड बाय अंडर 1 माइनस m स्क्वायर बाय c स्क्वायर
तो गामा का फॉर्मूला नहीं है, वो जब रिलेटिविटी
ये थ्योरी ऑफ
जब तुम रिलेटिविटी में जाओगे तो फिर स्पीड के साथ में बहुत कुछ होता है. When objects travel at speed of light, उसका मास भी इंक्रीज होता है. अभी तुमने पढ़ा है कि मास इज कांस्टेंट.
यस
So we are not in 9th and 10th discussing relativistic consideration. That is graduate and postgraduate.
यस
So ठीक है. That is for curiosity is okay. You want to discuss it. Okay. So I think is it time now?
Yes, sir.
1 minute left. You have anything to share with us?
No, sir.
Let the bell ring. So how did you like the pace of the lecture?
Very good, sir.
Pace is okay?
Yes, sir.
If you want any changes, you can just give your inputs. Anything like to be changed. All right, I'll see you in the next class.
गाड़ी में बच्चे किसने चेक किया? मम्मी ने। मैं कल एक और
एक दिन की मैम अगर आपसे ज्यादा नहीं है लाइक मैंने भी अभी मैम कंप्लीट
Reading 140 reading 126 14 बचा 14
स्कूल में ही है
खराब है क्या लॉजिक है इधर सोएंगे क्या
तेरा कितना परसेंटेज आ रहा है हां कितना एग्रीगेट घर पे कुछ बुक गिनूंगा सर
कुछ नहीं भाई वो तो मुझसे भी आ
क्या होगे
शाम
तेरा ही है
99 मिस हो गया उससे
क्यों मालूम है राउंड ऑफ 99 आएगा परफेक्ट 99
उसको लगा मुझे उसका मेरा परसेंटेज आ रहा है
मुझे 90 आया था
चलो भाई
90.7 आ रहा है
देखो कितना